But the next topic, as announced earlier, bless you, sir, bless you, is maritime and digital technology, the evolution of maritime technology. And of course, this evolution demands for safer, more efficient, digitally connected operations as we move forward. And from my perspective as a tech enthusiast, maritime industry keeps on surprising us with autonomous ships, with autonomous shipyards. And from one point of view, it seems that human involvement is needed less and less, but that may not be so. We will definitely see. That is where remote operating centers come in, opening up opportunities for improved safety, lower costs, operational efficiency. But who am I to talk about this? We have a wonderful moderator that is returning to our stage yet again this year. We're happy to see him all the way from the United Kingdom, the founder and director of On the Ley Line Limited. Ladies and gentlemen, let's give it up for Mr. Rob Watson. All right, Rob, take it away.
Thank you, Aldis. That's a bit over the top, but thank you very much. Pleasure to see so many people here. I think before we start, I'd just like each of the panelists to introduce themselves. I'm conscious of the time because we're going to have the big red timer up there. So if we can limit it to a couple of minutes each, and starting at the far end, Mac.
Brilliant. So my name's John McDonald, or Mac. I am the head of the Marine Operations Group for PML, I forgot where I work there, Plymouth Marine Laboratory, and that's a scientific research charity in Plymouth. I'm basically, as the title says, I'm in charge of all the operations on the water, so whether that be the autonomy, whether that be the crewed vessels, so a real mix of responsibilities there. I mainly deal with the operations, so for me, it's just ensuring that everything happens safely and that, however hard we're pushing technology, everyone comes home in one piece. So that's me.
Thanks, Mac. Andre?
I'm Andre Burgess. I'm the partnerships lead for the Assured Autonomy Program at National Physical Laboratory. So National Physical Laboratory, or NPL, is a government-owned lab. We are the UK's National Metrology Institute, so we manage the measurement standards, the SI units. But our main focus is to do a huge amount of research around that and develop the UK's scientific and metrology capabilities in this area. That's particularly important because that enables us to develop sort of the testing and evaluation methods and standards for emerging technologies, including things like quantum, AI, also do a lot of work in future communications, and obviously we deliver time for the UK, so that's a particularly important piece of critical national infrastructure. For Assured Autonomy, our focus is twofold. Firstly is how we develop or support the development of the novel and innovative test methods and infrastructure to assure autonomous systems, but also how we ensure that the infrastructure in the UK is fit for purpose, and also helping develop new standards around that.
Thanks, Andre. Kelly?
Hi, everyone. I'm Kelly Santos. I'm with the Fisheries and Marine Institute from Memorial University of Newfoundland. We're located on the very east coast of Canada, and I'm happy to say this is my first time at the event. It's been fantastic, so thank you for the invitation, and thank you to the organizers. At the Marine Institute, we conduct training, education programs, and research and development, all of which are very much applied. So we work with industry very closely to produce tangible results that our industry partners and our networks can integrate into their operations safely and efficiently and sustainably for our oceans. My role with the Institute is the director of our Ocean Innovation Center called The Launch. It's a facility located just outside of St. John's on the edge of the water in a small community called Holyrood. It's a safe, controlled, calibrated environment, but it's very much a real-world environment. Near Arctic conditions, harsh North Atlantic. It's what the Canadian federal government likes to call a living lab. So what we've done over the last 15 years is invested in this facility. We have the infrastructure, the technology, and the technical expertise to develop tangible solutions for our ocean sectors. And we like to brag a little bit that if it will work in Holyrood, if it will work there, it will work just about anywhere. Excellent. Thanks for having me.
Ansis.
Yeah, good afternoon, everyone. My name is Ansis Zeltiņš. I'm Chief Executive of Freeport Authority of Riga. We are practical people, and I would say we have put our fingers, even fingertips, into this digital ocean of autonomy. Together with our partners and with our friends. I should say that this is absolutely new territory for us, and most probably quite many involved in shipping and port business. But it's also clear that in order for nice and sustainable future with the best technology and also as a ports, as transport hubs, in order to be competitive, this is the must thing and direction we should go. So yeah, we some things we are being involved is kind of the fuzzy, so we are not. It's not absolutely clear where it's gonna take us. Some are more practical, but we definitely see that this is a future also for the port and port operators in order to be effective for future. Thank you.
Thank you, Artis. Artis?
So hello everyone. So my name is Artur Lindenbergs, Head of Innovations at LMT, which is, I would say, the biggest MNO or mobile network operator in Baltic states. So many of us about us think that we are just providing the data services and possibility to call between the phones, etc. But at least it's not about us. For 10 years, we are deep diving in different verticals. So, and in maritime, when we started collaboration with Riga Freeport and the LVR fleet, so we started with the question: is it possible to provide the 5G connectivity at sea? So for today, we know it's possible. So we have demonstrated. We had really good demo in mid of July, and so let's proceed with the technologies, how we can create completely new use cases.
Excellent. Thanks, everyone. So the focus of the panel today is largely around remote operations, as the title suggests. However, that only forms one part of the overall sort of area of marine autonomy. Andre, I'd like to ask you about the wider work that MPL is doing in that particular space, just to set the scene from an international perspective.
Well, I mean, firstly, the nice thing is we're actually working with everyone in some shape or form who's on this panel. We have worked with to some degree. But more importantly, as I mentioned, we have an assured autonomy program, and it's very about that assured bit. We don't do the development of the autonomous systems or the operation. But what we've done, we work mainly across the transport or mobility sector at this stage, mainly because that's a very major use case, and it involves a lot of safety critical issues, which is where we're more focused. The second part of that, we are working a lot in land, but not rail. As people point out, land does include rail, and everyone says, why not rail? We work mainly on self-driving vehicles, again, a lot of safety critical issues there. Work in aviation, again, low-level airspace, but maritime has been really our major focus over the last 2.5 years. And that's involved developing a partnership and a consortium with a number of organisations in the UK, including Plymouth Marine Lab and the University of Plymouth, who run the Centre for Coastal Autonomy, as well as Lloyd's Register, UK Hydrographic, Met Office, and other organisations as well. What we're doing with that is we've set up a programme of work called the Maritime Autonomy Assurance Testbed. It's not in itself developing a testbed. It is looking at how you use testbeds and test environments to develop the evidence to build an assurance framework, and one which is usable and reliable. And that's the most important thing, because at the moment there are a lot of barriers, whether it's regulatory or cost of testing, etc., which makes it very hard. This requires a lot of cutting-edge science, a lot of innovation. It's not, you can't just use the existing tools. There are some existing tools you can use. So our whole focus is what are those bits of innovation that we need to help develop. So MPL in that is doing some of the work itself, particularly around the metrics, the new metrics required, but a lot of our role is also coordinating and convening. And what that leads us on to is how we collaborate internationally. And we have had a lot of success, so we've started collaborating with Canada and Latvia. We also have a lot of collaboration in development or underway out in places like Singapore, Japan, and Korea. And the reason I mention that, these are very different maritime use cases for both autonomy and remote operations. Some are driven by demographic challenges, Japan and Korea, particularly aging workforce. Some are driven by the fact they have a very large high-value asset like Singapore Port, and others have major use cases with offshore infrastructure, fisheries, etc., a bit like the UK as well.
And with regard to engaging with the program, it's an open communication type thing that you're looking at.
But we talk to everyone. Obviously, we're finite in resource, so that sometimes that takes a bit longer than other times. But we are very open. So, and also, it's not just about the autonomy or the remote operations. This does cross over into everything to do with future smart shipping. Because the digitalization is doing two things. Firstly, it's creating a whole new requirement in terms of energy budgets and capacity, etc. But also trustworthiness in decision making, and a lot of the decisions are being taken away from humans.
Yeah.
How can we be confident in those decisions going forward?
Excellent. Okay, so if we focus back on the core ROC area, and this is a question for Mac. Obviously, ROCs are part of the overall MAT strategy. It's a fundamental building block. And there was some partnership work earlier this year between the UK, Canada, and Latvia specifically, really to look at creating recommendations for a standardized ROC infrastructure. Could you maybe summarize for the audience the main findings of that joint work?
Yeah, sure. Just to put that in perspective a little bit of the work that was done. It was three-day workshops in essence, and we basically travelled to each of these countries, went in each of us places of work to understand individual challenges, if you like, and then kind of put our heads together in 3 separate workshops to come up with, to do some problem solving and looking at the way ahead. If we truly want to put this into action rather than just talking about it, there was some serious work to be done. So a report was finalised, the final report from those 3 workshops. It had, it explained the work that was done, and ultimately it came out with, some conclusions and some recommendations. And those recommendations, I'm sure most of you have heard it this morning. One word that stands out is standardisation, and that was exactly what was said in the report. It was all about standardisation, and there was 4 recommendations, that approached that. And to me, it makes perfect sense because with the standardization, it's hard enough to ask all these different comms systems, to do as we ask without us moving the goalpost, so to speak. We keep changing our requirements. It changes for our partners. It changes in the environment. There are so many variables. So if we can make that easier, we can do that by employing standards amongst us all. So that's going to be 1, 2, 3, 4 less variables that is going to make that communications piece that much easier. So the 4 things that came from that report then, the 4 recommendations, were about standardizing hardware, software, data protocols, and remote operating procedures for the ROC. So the first one, hardware, should be pretty simple. It's just ensuring that every ROC is capable in the same way, that they can all do the same thing. So if you're asking another ROC to perform a task, it's got the right equipment to do so. So that should be an easy win. And that's the first one that needs to be put in place. Bear in mind the end product here, what we're looking for is handovers between international ROCs. So take, for instance, a boat sailing from Plymouth heading out to Canada. UK is in charge of it for half the trip, and then when it moves over, perhaps it gets halfway and Latvia wants to take over, and their ROC is in command of that, and then finally handing over to Canada for its transit in to Hollywood. Those transitions need to be seamless. Think about how air traffic control do it. It needs to be one of those kind of things. It needs to be, because if you get it wrong, if you lose communications with that boat, then that becomes a risk to the other water users. So by standardizing, putting those 4 standards in, you're going to ensure there's less chance of that happening. So the equipment is the easy win. And that there's already work being put in place to enable that. The second one then, software. I remember my own standards here. Software, that one is going to take a little bit longer. If you can imagine, each of these providers that currently run ROCs have their own individual software, individual to their platforms, and they're all, unfortunately, you can be locked out of these other software. So it's very difficult for me to operate my ROC and run someone else's boat when I don't have their software. So this software needs to be standardized to enable interoperability between different platforms. You then obviously got the data protocols. Now this one, you can't underestimate that task. That is way bigger than what this project is, and it's something that we'll be looking towards working on in the future. But that is really quite complex, and therefore, something to aim for rather than something that's going to be achieved in the near future. That is. And then finally, something that you can work out from day one, but will need tweaking all the way up until the end, is the operating procedures for the ROC. So how we drive a boat, how we approach hazards, even simple things like coal regs, is ensuring that all the ROCs are doing the same. We're all going to react in exactly the same way in these risky situations. So this should all culminate in a live demonstration in the near future, where I hope at least 3 of those 4 standards will be in place for us to take this forward.
Excellent, thanks, Mac. And I think we're just waiting for the final elements for that report. And I think the idea is that it will be available for people to study and look at and all of that sort of stuff. I think the other point is that this is really phase 1 of a program that's probably going to run for a number of years. So, and it's not exclusive to Canada, UK, and Latvia. It's very much about looking at globalized standards. As part of that, Artis, just turning to the communication systems, what are the main challenges of implementing a suitable system at sea is the first part of the question. You touched on it on your intro. And is that purely based on 5G, or are there elements of satellite comms as well?
Yeah, to provide the 5G connectivity at sea level, it's a really challenging task, because for us, for MNOs, it's quite simple and understandable how you can deploy the network on the land. You just build base stations, calculate the interferences, etc. But the maritime connectivity and the network at the sea level is all the time dynamics. It means that if we are deploying the 5G base stations and private networks on the ships all the time changing their location, etc. So we need to provide the predictive quality for the end users, in this case ships, buoys, drones, etc. And I think it's only one step of the challenge. The second one is we had some 1 year or one and a half year ago, we had a discussion with one ferry company, and the demand for today is already 1.6 gigabits per second to provide the connectivity. So how we can do it if it's impossible to do it only with the 5G or only with the satellites? That's why we started to dig in these 2 years ago how we can join these technologies. So it means we have developed the concept that actually, as we call it, free link concept. The ship could get the connectivity from the shore, but again, MNOs should change the mindset that they're building network not only for the land, but we should switch the base station to the sea as well. It's a first step. The second one is how we can provide the connectivity between the ships. And ships, as I mentioned, these will be like a private networks with the base stations, etc. So it means we are starting to create like a multi-hopping between the ships to provide the next step for connectivity. And the third is satellites. And many rumors are that satellites are competing with the 5G, but it's not so. We should look towards and change our mindset that actually the satellites and 5G can work together. In one case, it could be like a backup for backhauling. In the second case, actually, it could be like additional technology on top of that. But what is most important, the question is not about the technology only. It's about the use case. And for example, with the ROC, it gives like a huge challenge to provide the SLA that it really will work. And we should think about not only about the one link, for example, 5G or satellite, but about the redundancy. For example, if the one link will drop, what's happening next? So I would say that 5G and satellites, of course, will be like a joint technologies in the future.
Are they at the moment, or is there seamless handover from one to the next, or is that something that's potentially being developed?
It's possible to do it for today. This is a concept that we have developed, but we should take a next step, because at the moment you're just switching between the links, but as we see it, for example, if the ship will be connected to the satellite, 5G, and some other technology, we should understand how we can steer this traffic between the links. It doesn't mean that we are using just one of them, but it gives an opportunity to cover this demand for 1.6, 2 gigs, 3 gigs in the future, but to provide the real seamless connectivity based on the SLAs.
Excellent. Okay, thanks for that, Artis. Kelly, moving on to Canada.
Sure.
It's a pleasure to have you here, first of all. If we look at ROC operations and marine autonomy as two main focus areas here, is there anything that's specific to Canada in those two areas that you want to highlight? And the second part of that is, with those, are there any other challenges to be considered in your view over and above what we've already mentioned? So it's quite a broad sort of question, that, I guess.
Broad, but I think it's really relevant. So there's a couple of, I think, key challenge areas that are a bit unique to Canada, and they have to do with our environment. So they have to do with our geography. Canada is a very large country. We have the second largest coastline in the world, and when you look at the environments around that coastline, when you look at the diversity in the geography across our country, it's very challenging. So from where we're located on the east coast of Canada, we're on the edge of the North Atlantic. It's a very harsh environment. It's very unforgiving. So even within our own operating environment, we have challenges with performance, with communications infrastructure, just based on our very geography and the topography of where we live. If you move along the coast into the north, with climate change, shipping lanes and passageways are opening up in our north, but coverage areas are very limited. You know, the majority of Canada's cellular network is very much focused on its urban areas. That's where most of its population is. You know, from a business case perspective, that makes a lot of sense. But from, you know, the case of people living in rural areas, from an ocean monitoring and I guess our maritime sectors, from those perspectives, there's very limited infrastructure and there's limited capacity in many different areas along our coastline. And so from our perspective, that's actually one of the driving forces of why we've entered into the remote operations field. It's the result of working with our industry partners and recognizing these challenges and trying to address them in lockstep with our partners. The other challenge is in our environment. So when you look at demonstrating technology and integrating that technology into operations, it really needs to be able to stand up to the test. And so when you look at ocean technology, I guess in a general way, when you look at how quickly technology is evolving, and we've seen so much of that over the last couple of days, the technology itself is fantastic, but the application is very different. And so that's a huge role that we play as well, and a huge kind of driving force for us to move into remote operations and to partner with other organizations around the world, is to really be able to put that technology to the test, to demonstrate different applications, and to be able to provide that evidence-based research that's going to inform our regulators and to help drive the regulatory frameworks and the further development of regulatory frameworks. So definitely some challenges from a geographical perspective, but I think what it's resulted in is conversations and partnerships, which we're demonstrating here to learn from each other. What we bring to this table and what we bring to this partnership is Canadian perspectives that I think are a little bit unique, but that other organizations can take into consideration, which is really one of the reasons that we all came together, is to learn from each other.
Excellent. Thanks, Kelly. Obviously, we're focused primarily on marine autonomy here, ANSYS. But are there other areas of port and marine operations that would benefit from an overall ROC system?
Yeah, as I mentioned, as for a port or practical people, some of these things are still a bit fuzzy. So that means that, yeah, we have put our fingertips in the digital ocean. But definitely, I mean, port is not just a maritime. At least maritime port is not just a maritime. First of all, port is intermodal transportation hub at the wider or the smaller stage, depending on the port, but still. So that means that classically it's rail, road, and maritime. And all of these transportation modes, I think also if looking towards the future, will have definite autonomy. Okay, looking on the cars, and some are in science fiction still, some Mr. Musk is already saying that it's operational. Something you may see also on the rail, at least in airports where autonomous railway operations happen. So autonomous vehicles in container terminals is also not, I mean, it's not the science fiction, it's absolute reality. But all these things will become more and more. And also I think one big aspect, whenever we talk about the port, there are quite a number of small things. I mean, here we're talking like remote ship operation, in order looking towards the future, like ship sailing from Riga to Halifax, crossing the ocean at a bigger scale. But there are a number, and those most probably will be the first and also most tangible things and realistic things in the ports, which happens and which might be automated already at this point of time. Some are done already. Also in Riga, we are, and it's not about only the drones flying on doing surveillance, which is also not anymore science fiction, but it's also different floating and even submersible things, which helps providing different services within the port, different measurements, different assistance functions, which previously was done by one or another vessel or size of the vessel, which was operated by a crew, where most of the function was just operating a vehicle. And this is quite first of all, commercial, financial benefit, and it's also operational benefit. It provides much more flexibility in the things what you are doing. And I think this is at least how we in a port are looking towards that. Different ports have moved different, slightly maybe different direction. Particularly in Riga, I think what we see at the water level, all internal port operations at some point, most probably, I don't know, tugboat assistance, for instance, definitely pilotage has a thing, because first of all, its safety aspect is dangerous. So coming out on a boat in a rough weather, boarding a vessel, or disembarking from a vessel, it's a dangerous thing. And that is a part which definitely could be automated. And then it comes to what my colleague said, question to the seamless transition, let's say, exchange of data, because it's also the fact with automation, the volumes of the data needs to be transferred becomes more and more, and that's inevitable. I mean, even if you look on our smartphone, so it's not becoming bigger, but different brains in the phone are becoming more and more sophisticated and needs more possibility to transfer data.
Okay, brilliant answers. So just wanted to pick up on something you said, Kelly. And this is actually for the panel as a whole to answer. There's no specific person to answer it. One thing that's been a common issue every time I've come here to do these types of conversations is regulations. So it's a kind of an open question, and it's a bit of a curveball for everybody on the panel, I think. But where are we actually at with regulations with regard to marine autonomy at this point?
Mac answers the detail.
Yeah.
The UK on that one. But I'm going to... There's a lot of school of thinking that says, oh, the regulation's holding everything up. But there is a good reason why the regulations are there and the way they do things the way they are. And there's also another school of thought that actually the regulations aren't necessarily the problem.
Yeah. Let's
not forget, in the maritime space, a lot of the regulations started several hundred years ago, very paper-based, based on wooden ships, etc. They come out of some very clear lines of thinking around safety at sea, etc. and chains of responsibility and those types of things. And taking people off ships who are meant to be in control presents a huge, huge challenge for that. So there is an onus on the technology developers also to demonstrate to the regulators that they're fit for purpose, and that's one of the challenges, I think. I know there's a lot of people who say the regulation's just a barrier. It's not. And another reason I point to is that even with very small remotely operated vessels, which might seem there's no safety hazard, if there was no regulation, you might find 10,000 of these in the water and suddenly that's a hazard. So the regulation is there mostly for a very good reason. But what I will say before I hand over to Mac to talk about the specifics is that I forgot my change of thought there, frankly. I'll hand over to Mac on that one.
We can come back to it, Andre, it's fine.
Thank you, Andre. So, where is the UK? Okay, so the MCA and Department for Transport, they're obviously, they're the ones that put out the legislation for the UK. And what they've decided to do is focus on the vessels under 24 metres. So a lot of the USVs and the autonomy, there's not many that are above that limit. So at the moment, the easiest way was to try and mirror existing regulation for manned vessels, and they've tried to do that to a degree with autonomy. The problem is square peg, round hole, it's not always going to fit. And that's where we're meeting some of those challenges. So the regulation that's come out, the problem being is that gap between 1 and 24 metres is quite evident when you look at the regulation. So, and rightly so, they've gone straight in heavy at the upper end of the scale. Okay, what's the worst case scenario? A 24 metre uncrewed vessel in our harbours that's lost control. That's worst case scenario. How do we avoid that? And that's where a whole bunch of measures have been put in place that each of these operators must have on their vessels to ensure that that never happens. The problem being is the vast majority of local operators, and certainly the innovators, their vessels are well below 10 metres. I think 7 metres is the average length overall of a lot of these vessels. And the real issue we have is the requirements that the legislation puts out we're physically unable to meet. Technology hasn't quite met that yet. So there's a real balance as to what's too much and what's too little. Take for instance these 7 metre, 5 metre vessels, they're there to do survey. Once they've got all their survey payload on, to then get all the additional layers and redundancies that the MCA will ask for, you physically can't fit it on the vessel, and it then needs to be quite a bit larger to encompass that. And this legislation has come out a little bit after everyone's built, so to speak. So they were kind of chasing their tail a little bit. So a lot of these operators, they built, or the designs were put out when there was no legislation. So they built it, they've done their R&D on it, they want to go and use it commercially now to regain some of those costs. And the problem being is the legislation's turned up and they don't fit. So we're now at the point, I'll give credit where it's due to the MCA and the other bodies that put in the legislation. They are now conversing quite heavily with us as stakeholders as to how we can change this. So they are very slowly starting to, I won't say make exceptions. There's always been a process where you can put in a safety case and you can get your vessel through that load line exemption. Albeit, it's quite a difficult process. They're now looking at broader exemptions like MGN 702 that allows vessels, say for instance, under 2.5 metres, can now operate much more freely with a much smaller requirement to do that legally. They're now looking at something termed mini-mass, and I think at the moment they're looking at a limit of around, I think it's 4.5 metres, which is not quite where we want to be, but again, we don't want to, we still need legislation. We still need these things put in place to protect all the users, but also the other water users out there. But at the same time, it's got to be workable. What we don't want is to strangle innovation within the UK and potentially, send it to other places where perhaps that grasp isn't quite so tight. So it's an ongoing process. There's a number of other projects that are being developed at the moment to assist with this. Take, for instance, there's a MRIF project. Now I've got to remember what that means. Marine Regulated innovation framework. In effect, I should have just said it, it's a sandbox, it's a test bed, and that's what we're looking to do. We're hoping to work with the MCA to develop a framework that enables R&D testing of certain vessels to gain the evidence for those safety cases to get them legally through that process. So it is a little painful in places, but it's to be expected. And everyone's working quite well together and quite hard to to make sure that we can get as many vessels through as safely as possible.
Excellent. Andre, have you remember what you were going to say?
It was that wonderful word standards, but not just standards. So we work with the regulators across transport, not just in maritime. And one of the things that they really look for is good evidence.
Yeah.
But that evidence needs to be standardized, otherwise it's very hard to interpret the evidence. So standards, the right types of standards, particularly standard on things like taxonomies as well and vocabularies to start with, and good quality evidence will really help because that will shape how regulation evolves in this space.
Okay. And Kelly, just touching on Canada again, is it a similar situation there?
Very
Who
similar.
You go?
Yeah, so the Canadian landscape is very similar. So we work with the federal government, Transport Canada. I think you described it best, the cat chasing its tail a little bit. Very much focused on larger platforms. Having said that, kind of as an interim measure, there is an application process for the smaller platforms. And to echo Andre's comments, it's often seen as onerous, or it's seen as a barrier, or it's seen as stifling innovation, as Max said. But it's necessary. When you look at an environment like the launch, like Holyrood Bay, it's not St. John's Harbour, it's not Halifax Harbour, but there's still commercial fisheries, recreational boaters. There's still a fairly significant amount of activity there, and for us just to be able to put our platforms in the water, we need to do our due diligence, and so that application process is very necessary. We are playing a similar role in that we see the need for that sandbox. We see the need for the test bed that cuts down on some of that administrative burden, makes it easier for technology developers to put their platforms in the water, to do that demonstration a lot more quickly, and to produce that evidence-based research that the federal government needs to inform policy. And so we're actually undergoing a process with the federal government to establish our waters and our facility as a designated test zone for that purpose. We really see ourselves as playing a key role in helping to shape policy for that reason. And a key aspect of that is the work that we're doing with remote operations, being able to demonstrate that through standardized remote operations, we can effectively monitor and effectively operate these platforms is absolutely, it's crucial to moving this whole space forward. So.
Excellent, thank you. Ansis, I guess the same question around Latvia. I'm assuming it's going to be a similar answer.
Yeah, on the regulation, that's most probably not the direct question to me, but knowing the system, I would say I would split it in two parts. And as my colleagues mentioned, while we are talking about something small, whatever that small is, but at the level of, let's say, to my mind, floating drones, which perform one or another auxiliary operation, I think in most cases it will fit with a national regulation, and then it depends from country to country, so how and what strict from the point of liability and operations they are going to be. The biggest challenge will start whenever we're going to talk about kind of the autonomous ships starting carrying people or cargo and going on international trade, because then we start about liability, international law, standardization, and whenever politicians, policy, and lawyers are getting involved, so then it becomes complicated.
Yep.
And I think that's the biggest challenge, because take very simple thing, how many electric plugs, types of electric plugs do we have in Europe? At least 3.
Yeah.
And it's already nearly a century, okay, not a century, but close to that, and it's not being standardized.
Yeah.
And how many years took USB-C to become a standard on a phone, which is a simple thing, was developed years ago.
Yeah.
And I think that's the most complicated thing, and that's, I think, the standardization, at least in I would say also in shipping, it goes way beyond, way behind the practical development of technology.
Excellent. Artis, anything to add to that from your side?
Yes, I can maybe split the standardization and regulation in several parts, but I can comment on communication, because there is regulation on ROC, regulation on maritime, connectivity, cybersecurity, etc., so on. But if we are talking about the communications, then for today we are speaking about the 6G for the future. It will be in 2030. Who knows what will happen in 2030? We can just imagine. The same was with the 5G. When these standards was developed in 2018, 2019, I think, if I'm not mistaken, then who could imagine that actually the 5G could be possible to deploy on the Baltic Sea level? So nobody. And I would like to say that we can't regulate and standardize what we don't know. That's why there are two parts. Regulation can push the technology, or technology can push the regulation, but we should find the middle way.
Yeah.
That's why we should join the forces with the maritime industry, communications industry, etc., so on, and take a decision what is next.
Yeah.
So not to wait for something what will shoot out and then try to figure out how to regulate it.
Yeah, it's a very good point. I guess the takeaway on all of this is collaboration is key. It's not just the specific technology areas, it's also the geographies that are involved. So I guess the takeaway is standardization is where we want to get to, but that is an open conversation. So Aldis, I think we finished with the questions here. Have we got any questions from the audience or online?
Yes, we're going to give you the opportunity to ask questions. Before that, we're going to put up a QR code on the screen where you can evaluate this talk right now. Give us a mark, give us some feedback so we improve for the next events to follow. That is number one task for my side. But do we have any questions in the audience? A lot of invested people. There's a question right there, maybe on this side. Let's start with you. Hello, what's your name and your question?
Kevin Collis. It's a question about the port. So you're clearly being focused on supporting the activities to do autonomy in the port. When do you need to start making a profit out of autonomy for it to be something that will be supported longer term?
Maybe never. But no, of course, on the practical side, it was to me, huh?
Yes.
Yeah, on the practical side, as I mentioned, some of the things for us seems to be fuzzy. So that means that on the practical side, you not always see the practical return. So what or whether we're gonna do that in the practical operations in the port. But we also clearly understand that without that, we will never ever get a touch, or at least as a first movers, to the technology and innovation. And I would say that and I mentioned that already, at least in Riga, and it's also nothing specific. Also, other ports are using more or less the same technologies. I mean, we use remote operated floating vehicle, let's say, for hydrographic measurement, which before was, and we still are using our hydrographic vessel. So it's first of all expensive asset. It needs a crew. It needs shifts of the crew, and that all costs money. For floating drone, we don't need a crew. We can put it in a trunk of the truck. We can bring it everywhere we want to. So we don't need all the vessel-related dry docks and all the things like that. So, and that's the pure economic efficiency thing. Some, like whenever we talk about 5G at sea, we see the benefits as the theory. How it's gonna turn out, it's another question.
Okay.
All right, any more questions in the audience? Yes, there's one.
Well, thank you. Very interesting debates. So my question is to all of you. My name is Yanis. Sorry. actually, what will be the next step? What do you think? What is the next step for collaborate and standardize all this what we talking about? Yeah? Because we have some technology in place, we have a demand from industry. What will be a next step? Thank you.
Andre, do you maybe want to pick that up to start with?
Building the evidence is very important here. So doing the right type of research, and that's where international collaboration helps. We do the right type of research and we can demonstrate correlation, compatibility. That leads to things like standards, but it gives confidence to industry that if they develop something, it's not going to work in just one place, but in lots of places and be used there. And I think that's a very important component of international collaboration.
Any other?
Just to add to that, I think that the diversity in the partners that are here on the stage, and we're all individually working with other entities around the world, I think that is really going to create much more robust evidence at the end of the day. Different use cases, different environments, different challenges. Sharing that information, the knowledge exchange alone it's incredibly valuable and will help shape a much more robust, I think, standardization at the end of this process, or as we move forward. I don't know where it ends.
I was going to just echo what Kelly was just saying there, that we need to keep this partnership going and let it grow, whether that is bringing in new partners or whatever that looks like in the future, but expanding our knowledge and sharing each other's experiences. So physically getting the vessels in the water and making a reality what we've just been talking about. So it's already been done to a degree, but to go ahead and, to push it to the extremes and to move it forward at pace with technology. So like we said, we don't know what it's going to look like in 2030. So who knows what we're going to be talking about at that point. But if we can maintain, these working groups, these friendships that we've got now, we're going to be in a better place to deal with those challenges.
I don't see any raised hands right now. I have a question here. If ships and remote control centers become digital, will pirates be able to take over a ship from a living room sofa?
Who wants to pick that one?
Digital pirates, I mean.
Yeah.
Okay. No, my point. It's already now. I mean, it's nothing to do with automation. I would say already now. I think the security of data and the communication channels is absolutely paramount for ports and maritime, and I think that only will be evolving. So. If something can be developed, then something can be also hacked. So it's like if there's the bank, there's a possibility to rob it.
Yes.
Yeah.
So Mac,
I think it's worth adding that it needs to be proportional. If the pirate takes over a 2-meter survey vessel, what's it going to do with it? Not a lot.
How's it going to take it over?
Well, exactly. But the cybersecurity, say, for a 100-meter vessel that's doing autonomous logistics, that's going to be far more advanced than anything, on that smaller scale. So it's with all these measures, it's got to be proportional. So, yeah, I don't think the pirate is going to take the 100-meter vessel, but if he does take the smaller one, he's not really going to be able to do much with it, so to speak. But from the living room, that's perfectly possible. We do that already. Not with the pirating bit.
Your spare room, as you said.
Yeah, my spare room. Yeah.
All right, well, that's it from my side. No more questions here. If we don't see any raised hand, then I want your hands to be put together for a round of applause to our amazing panel and our moderator, Rob Watson.